Good morning, students. So yesterday we have finished in the last class belt drives. Okay, we have solved problems also. The last topic in belt drive is condition for maximum power. Okay, now we are moving to another topic in fourth unit, that is gear drives. In this fourth chapter, we are having belt drives and gear drives. We have finished belt drives. Now we are moving to the gear drives, right? So on completion of this lecture, we are going to know about the what is a gear and advantages and limitations of gear drives, types of gear tooth profiles, and types of gears. So before going to discussing the topic, just observe this animation. So one is a driver and another is the driven. So in this picture, we have observed two types of gears based on teeth profile. So you are viewing animation of mating machine element. So these are called gears. Gear. What is the definition? A toothed wheel having a special tooth shape or profile enabling it to mesh smoothly with other gears. A toothed wheel. This is a wheel. It is having teeth. These are called as teeth. So can call it as a special tooth shape or profile, enabling it to mesh smoothly with other gears. So it is meshed with other gears because the motion is transferred only by this way. By using gears, the motion is transferred by this way, mating of gears. So use it to transmit power from one shaft to another shaft, that is driver shaft to driven shaft, which are very close to each other. So we can recall belt drives. In the belt drives, the two shafts having pulleys, and these two pulleys are connected with the belt. But here, the wheels are equipped with teeth, the wheels, and these wheels are close to each other. There is no media between these two wheels. They are directly contact with each other, right? So the driver shaft and the driven shaft are very close to each other in gear drives, whereas in belt drives, those are connected with the belts. Okay, so that is the definition of gears. A toothed wheel having a special tooth shape or profile enabling it to mesh smoothly with other gears, used to transmit power from one shaft to another shaft, which are very close to each other. Advantages with the gear drive over belt drives. So it is a positive drive. Okay? So there is a power transmission. Positive means we are always getting good power transmission, right? There is no slip occurs in belt drive in gear drives. That's why we have called it as a positive drive and more compact. The distance between two shafts is very less, so that's why it is very more compact and used where the constant velocity ratio is desired. In the last class, the belt drives, we have discussed about the velocity ratio, that is speed is inversely proportional to diameter, right? N2 by N1 is equal to D1 by D2. Here we are getting constant VR. Constant VR. The velocity ratio does not change because the two shafts are closer to each other and it is operated at higher speeds and reliable in service, higher efficiency, wide transmitted power range, and lighter loads on the shafts and bearings. Okay, it can be operated at higher speeds compared to the belt drives, and it is reliable in service compared to the belt drives, and it is very high efficiency and transmitted power range is very high and loads on the shafts and bearings is less compared to the belt drives because we are not using any other device. The wheel itself having teeth. And coming to the disadvantages, it is not suitable for the shafts which are at longer distances. Okay, so for longer distance power transmission, we are going to the belt drives. So gear drives are not suitable, and perfect alignment shafts is required. Here, two shafts with mating gears are connected with each other. That's why here alignment problem is high and unable to absorb shock in services, and it cannot absorb shocks while in service. So far we have finished what is gear and advantages and disadvantages. And the gear, if you are observing gear, it is having wheel. On this wheel, it is provided with the teeth. The teeth may be different types, right? Wheel is having teeth on its top. They are called as gears. So the teeth having different profiles. There are two profiles in which tooth is formed or generated. They are cycloid and involute. In first year drawing, we have drawn these two drawings, cycloid and involute. With this, we are generate the tooth profiles of gears. Cycloid. As you observe, cycloid, one of the first regular profiles used for gear teeth. So this is the first gear tooth we are using while generating the tooth profile. It is not widely used because of difficulties encountered in producing accurate profiles. So it is not widely used because of difficulties encountered in producing accurate profiles. And coming to the involute, gears with involute profiles are in general in use. So generally we are using these gear tooth profiles, involute teeth profiles. These are particularly useful where great strength and practically no backlash are important factors as in motor car gears. So backlash, this is the new term you are observed here. We will discuss about this backlash next session. So gears with involute profiles are in general use, are particularly useful where greater strength and practically no backlash are important factors as in motor car gears. Right? So these are the tooth profiles. We are with these tooth profiles, we are generating the tooths of the gears. Okay. The gears are nothing but wheels having teeth on its surface. You can call it as a gears, and these teeth are generated by two profiles. One is cycloid and another is involute. The cycloid is the older one and is not widely used, whereas involute is the new one and we can use generally. Next, coming to the types of gears, we are having different types of gears according to the following features: the relative position of shafts, that may be coplanar or inline or non-coplanar. Based on the position of shafts, we can differentiate the gears, and the position of teeth with respect to the gear axis. They may be parallel or they may be perpendicular to each other, right? They may be inclined. So position of teeth with respect to gear axis also we will divide the gears, and form or profile gear teeth, the cycloid or involute form of teeth we can divide with the cycloid teeth or involute teeth, right? So these are the three types dividing the gears: relative position of shafts, position of teeth with respect to gear axis, form or profile of gear teeth. So these are very, very important interview point of questions. What are the types of gears? And you have to explain each gear by mentioning its name with description. The spur gears used to connect two coplanar parallel shafts that can be observed in our next slide with the diagram. In this spur gears used to connect two coplanar parallel shafts. The shafts are in same plane. Bevel gears used to connect two coplanar intersecting shafts. Spiral gear used to connect two non-intersecting non-coplanar shafts. Work gears used to connect. These are worm gears, not work gears. Spelling mistake. Used to connect screw shafts, that is non-coplanar shafts, which are at right angles. Right? You can observe in the diagram various types of gear. Classification of gears on the basis of relative position of teeth with respect to gear axis. 1. Straight gears, that is spur gears. Teeth are parallel to the axis of shaft. Observe here. The teeth which are provided on the wheel of the gear is parallel. These are teeth profiles. These are parallel to the axis of shaft. We can call them as spur gears. So spur gears are always parallel to each other while connecting. So teeth are parallel to the axis of shaft. Helical gears. Teeth make certain angle with the axis. In helical gears, teeth are. So observe here, the profile of teeth is inclined to the axis. So these are helical gears. Herringbone gears. So profile, we have to observe the profile of the teeth. Here parallel to the axis of the shaft, spur gears. Helical gears inclined to the gears, inclined to the axis. Bevel gears. So observe here, bevel gears are the axis of two shafts are perpendicular to each other. So these are used in our motor vehicles. The rear gear drives are bevel gears. Spiral gears and worm gear to transmit linear motion to rotary motion. We are using worm gear. Okay. And coming to the gear material, commonly used gear materials are cast iron, alloy steels, bronze, and plastics. Low speed gears with medium loads and suffering no shock are made of cast iron. Large gear wheels are made of normalized plain carbon steel. For high strength and good wearing qualities, the gears are made of alloy steel such as vanadium, chromium steel. Okay, so these are the gear materials. Generally, we are using commonly used cast iron, alloy steel, bronze, and plastics. So where cast iron is used, low speed gears with medium loads and suffering no shocks. The large gear wheels are made of normalized plain carbon steel. For high strength and good wearing qualities, the gears are made of alloy steel such as vanadium and chromium steel. And gears made of nickel bronze resist corrosion and widely used in worm gears. And plastic gears are less noisy, but they are inferior to metal gears in load carrying capacity, durability, and reliability. So these are the gear materials, right? Generally, we are using cast iron, steel, bronze, and plastics. Okay. For low speed gears, we are using cast iron, right? And for impact strength, for large gears, we are using plain carbon steel. And the gears which are resist the corrosion, we go for the nickel bronze. And for the less noisy and load care capacity is more, we are go for the plastic gears. Okay. So what is the gear and the types of gears and gear materials we have finished. Now we are moving to the spur gear nomenclature. So as we know that spur gear is the teeth on spur gear is parallel to the shafts. Right? In helical gears, the teeth are inclined to the axis of the shaft, whereas in spur gear, the teeth is parallel to the axis of the shaft, and these spur gears are used to connect two coplanar parallel shafts. Right, we have to remember this. Spur gears are used to connect two coplanar parallel shafts. So spur gear nomenclature means, so what are the parts in gear teeth profile? What are the parts having on gear tooth profile? We have to discuss, right? So here this one is the addendum and it is dedendum, and the pitch radius, circular pitch, pitch circle, dedendum circle, face, flank, fillet, addendum circle. So this figure shows the mating while two gears are mating the position. Tooth details, pitch surface, face width, and face. So we have to discuss each part of this nomenclature, right? That first one, a circle representing imaginary friction wheel is known as pitch circle of the toothed wheel. A circle representing imaginary friction wheels is known as pitch circle of the toothed wheel. So this one, so this is the tooth profile. It is a wheel. On this wheel, the wheel is having teeth. So the circle which is passing through this diameter, right? The circle representing imaginary friction wheel means, here, observe here, mating. So this is one gear and it is another gear. These two are mated at this position. The motion is transferred by this meeting only. So this meeting point here also meeting to teeth profiles. So we are drawing now a circle at this mating point imaginarily. Imaginarily we are drawing a circle passing through this meeting point. So we can call this as a pitch circle. Okay, a circle representing imaginary friction wheel is known as pitch circle or toothed wheel. Circular pitch, the distance between the corresponding points of successive teeth measured along the pitch circle, equal to the width of the tooth and a space measured on the pitch circle, given by formula, that is pitch circular pitch. PC is equal to pi d by t, where d is equal to pitch circle diameter and t is equal to number of teeth. In the simple terms, the distance between the corresponding points of successive teeth measured along the pitch circle. And coming again to the diagram. So this is the mating point of gears here, the mating point. So from here to another mating point of gears. This is the first mating point and it is another mating point. So the distance between these two is called circular pitch. Okay, the distance between these two are called circular pitch, and it is measured along the pitch circle, and it is equal to the width of teeth, and it is equal to the width of teeth. The circular pitch is equal to the width of teeth. We can calculate this value by pi d by t. In this, d is equal to pitch circle diameter and t is equal to number of teeth. And the diametral pitch, it is the ratio of teeth of a gear to the pitch circle diameter, that is t by d. So very important, diametral pitch, because the next one is reciprocal to this diametral pitch. Okay, diametral pitch, the ratio of number of teeth of gear to the pitch circle diameter. PD is equal to D by D. Number of teeth may be 20 and the diameter is 5 of the wheel. So what is diametral pitch? 20 by 5, that is 4. Where PD diametral pitch. And module, it is the reciprocal to the pitch circle diameter, the ratio of pitch circle diameter in mm to the number of teeth. That is, it is reciprocal to the diametral pitch. Very, very important module and the diametral pitch. That is T by D, and this is D by T. Don't get confused. Module is the reciprocal of diametral pitch. Module and circular pitch must be same for gears in mesh. The recommended series of module in Indian standards are 1, 1.25, 1.5. You can get up to 50. Next, addendum circle. Circle passing through tips of teeth. Observe the diagram. So this is the tip of teeth. This is the circle. Addendum circle means the circle passing through the tips of teeth is called addendum circle, and the circle passing through the roots of teeth. So this is the root. Okay. So the circle passing through the roots of teeth is called dedendum, and the dedendum circle, and the circle passing through the top of the teeth is called addendum circle. Okay. In between is having pitch circle. So circle passing through tips of teeth, and the dedendum circle, a circle passing through the roots of teeth. Addendum means addendum circle, dedendum circle, and next addendum. It is different to the addendum circle. The difference between the distance between the pitch circle to the tips of teeth is called addendum. The radial distance between pitch circle and addendum circle, because addendum circle is passing through the tips of teeth, and the dedendum circle is passing through the roots of teeth. In between, we are the gear is having pitch circle. So now, addendum means the radial distance between the pitch circle and the addendum circle. Dedendum, the radial distance between the pitch circle and the dedendum circle is called dedendum. In the diagram, we have observed. So this is addendum, and this one is the dedendum. The radial distance between the pitch circle and addendum circle. Here the dedendum means the radial distance between the pitch circle and the dedendum circle. Clearance, difference between the dedendum of one gear and the addendum of the mating gear. Okay, addendum of mating gear and the dedendum of mating gear. The gap between these two is called clearance. Here, this one is the clearance. Understood? This consider addendum botundi, consider dedendum botundi. So, in between these two, we are having the clearance. Okay. Next, working depth. It is defined as the sum of the addendum of two mating gears. Working depth means, so this is the addendum of one gear, addendum circle, and this is the another addendum circle. So the working depth means up to here, from here to here. If we are drawing one radial line, we are getting the working depth. So it is defined as the sum of the addendum of two mating gears. And pressure angle. It is the angle between the common normal at the point of tooth contact and the common tangent to the pitch circle. And backlash, very, very important, backlash. The backlash, the difference between the thickness of engaging tooth to the width of recess on the pitch circle, is the difference between the thickness of engaging tooth to the width of recess on the pitch circle. So we know that circular pitch PC is equal to pi d by t, that is equal to pi into t by t, pi by diametral pitch. ఇక్కడ పై d by t కదా, పై d ని కిందికి రప్పిస్తే ఏమైతుంది, t by d అవుతుంది. పై t by d అంటే ఏంటి, diametral pitch, pi by pd. So circular pitch is equal to pi by pd, that is PC into pd. Circular pitch and diametral pitch is equal to pi. Example, a problem with them. A wheel has 48 teeth and circular pitch 24 mm. Find pitch circle diameter and diametral pitch. We know pitch circle diameter PC is equal to PD by T. PC ఇచ్చిన 24 mm అని, PD ఇవ్వలేదు, teeth ఇచ్చిన 48 అని. అందులో నుంచి D is equal to 366.8 mm అని వచ్చింది, diameter of the pitch. Okay. Next, PD is equal to T by D, diametral pitch అంటే ఫార్ములాలు ఉన్నాయి మన దగ్గర ఆల్రెడీ. టీత్ ఉన్నాయి 48 బై 366.8. సో పీడీ ఎంత వచ్చింది, 0.13. నెక్స్ట్, a gear of 44 teeth has PCD of 352 mm. PCD means pitch circle diameter. What is its module? Circular pitch and num. Circular pitch P into D by T, P into diameter in the 352 divided by 44, that is 25.13 mm వచ్చింది. Next, D by T 352 divided by 44 and addendum 1.25 into M, 1.25 into 8. Module కదా, ratio reciprocal కాబట్టి అట్లా తీసుకున్నాం. Okay, so with this I am concluded today's session.